Hello students, welcome to Long Editex. Today I am going to bring you here videos about how to find the oxidation states of the different element in the different compounds. Okay, so let us see here along with the questions here. So find the oxidation states of the following underlined elements from the following compounds or ions. So sometimes the compounds are of in the form of the neutrals, or say some are in the form of the ions having the positive or a negative charge. So there how we can find out the oxidation state of an element. Some elements used to have the different oxidation state, having the variable oxidation state, having the more than one oxidation state used to be there. Okay, so according to their compounds here, different oxidation state will be there, and then this oxidation state, how we can find out, that's only I am going to show you today. Okay, let's start with the questions. Here, first of all, here I underline here, so this is the sulfate ions. So here we are going to find out the oxidation state of the sulfur in the sulfate ions. So first of all, here it comes to SO4 minus 2. Solution here, what we can do here, we are going to find out for the sulfur. You can take as X. If you don't want, what you can do, you can write S plus. That means that in between all these elements or whatever the elements you have here, we have to add a plus. That means that some, okay, and then here this 4 belongs to not for the sulfur, this belongs to the oxygens. Okay, so that will multiply with 4 only. Okay, so O into 4, and this is charge as a charge for this ion. So it comes to minus 2. So you will write beyond equal to, that is minus 2. And then now what will come? We will come about the valency. So here we have to know the valencies. Okay, if you don't know the valency, again it will be a problem for you to find out the oxidation state. So I highly recommend you to find out the valencies of the elements. Okay, so here it comes, here sulfur plus oxygens. The valency of the oxygens is minus 2, so it comes to minus 2 into here 4 is equal to minus 2. Then sulfur, bracket close, here then it's open, then 4 to the 8, then comes to minus plus multiply, it comes to minus 4 to the 8 is equal to minus 2. Okay, therefore sulfur we will transport here in this side. Then if its transportation is done, then its sign will change. The minus will change to plus. That comes to minus 2 plus 8. It comes to how much? That is the sulfur oxidation state will be, that is the plus 6. Okay, so therefore, oxidation state of sulfur in SO4, that is sulfate ion, is, what is that? Plus 6. So like this, we can find out the oxidation state of the different elements. So this is for the first one. Let us find out for the different elements in the different compounds or the different ions. Okay, now for the MnO4. So second number now here. So this is what manganese oxide, right? MnO4 minus. Okay, and here solutions here. We have to find out for the manganese in these ions. Okay, so here, yes, you can write Mn, or yes, you can take X. I told you, let X be the oxidation state of the manganese. Like that also you can do, or not, just Mn, no problem. Plus, there will be the sum between all these elements and the oxygens into 4, because the 4 is for only oxygens, right? Is equal to, here is minus. Minus means what? That is minus 1. We must be very careful about minus. Minus are very dangerous, right? So here Mn plus, oxygen's its valency is minus 2 into 4 is equal to minus 1. Then here it comes to M and, okay, so here minus. Why? Because when we open the brackets, minus 2 into 4, that comes to minus 4 to the 8 is equal to minus 1. Then here will come here Mn, we will transport here is equal to, if we transport here, then this will come here minus 1, minus will change to plus 8. Okay, so therefore what will be? Therefore oxidation state of the Mn will be what? That is the plus 7. Because the minus 1 plus 8 is 7 only. Let us see for this is a neutral compound, that is the H2SO4, which doesn't have any charged ions here. So for this here, what we have to find out? We are going to find out for the sulfur. Okay, oxidation state of sulfur. So H2SO4. So here, what we have to do? There is the hydrogen. Its valency will be here, but hydrogen, this 2 belongs to for hydrogen, so it's into 2 plus sulfur plus O into 4 is equal to how much we will write? This is the neutral, so we will put here 0. So hydrogen, its valency is -1 into 2 plus sulfur is, as we will put here, oxygen, as you know, that is -2 into 4 is equal to 0. So 1 into 2 minus 2 plus sulfur minus here also how much will it be here? Yeah. Oh, sorry, this hydrogen is not minus, this is plus only. Okay, so 1 to the 2. Okay, and then here minus 4 to the 8 is equal to 0. Then plus minus, what we'll do? We will subtract, right? Then S minus 6, because bigger signs, okay, we take the sign of the bigger number, that is minus, and here it comes to minus 6, that's equal to 0. Therefore, oxidation state of sulfur is, after transportation, here will comes plus 6. So like this, oxidation state of sulfur in the H2SO4 is also plus 6. Okay, let's come for the ammonium ions. So we'll find out the oxidation state of the nitrogens in these ammonium ions. Okay. And in this number 4 may here and is 4 plus. Okay, so in this case here we need to find out for nitrogen. Here it comes that N plus 1, that is, I will write it, make it longer, 4 is equal to plus. Plus means 1. Single 1 ions is there, I mean the positive charge only. So nitrogen plus hydrogen 1 into 4 is equal to 1. Then comes to nitrogen is equal to 1. The plus, if we transport, then it changes to minus. Now, so therefore, oxygen state of N in NH4 plus is how much? 4 minus 4, and 1 minus 4 is minus 3. So like this we can find out. And the last ones, here is the first step, and we will find out the oxidation state of phosphorus. Okay. So in this case here, in the number 5, here PO4 minus 3. This is a charged ions only, so solutions here. P, okay, I am doing directly here, plus oxygen valency is minus 2, as you know, minus into 4 is equal to minus 3 will be here. Then therefore P minus 4 to the 8 is equal to minus 3. Then therefore P is equal to minus 3. If we bring the minus this side, transport, then plus 8. Then therefore oxidation state of phosphorus is how much? That is plus 5, because minus plus minus sign of the bigger number we take here. So like this we can find out oxidation state of the elements in any compounds like this. So the different variable oxidation state of the different elements we can find out from there itself by following the rules whatever I explain here for any elements in any compounds. I hope you enjoyed the video. Thanks for watching, and don't forget to subscribe and click on the bell icons for the latest information. Thank you.